Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be starting Section 3 of Chapter 4, Solving Systems of Linear Equations by Elimination. So our first problem under Problem 1, Solving a System by Adding Equations, asks us what is the solution of the system x plus y equals 7 and 2x minus y equals 2. So in order to use elimination, we have to have either our x values cancel each other out or our y values cancel each other out. So what we want to do, we want to look and see if our x's are opposites of each other, like we have a positive and negative of the same number. So if I look at my x's, the first equation is just x, the second equation is 2x. Those won't cancel. So then I move on to my y values. I have a positive y and a negative y. Those are going to cancel each other out. So I draw a line through them, and then I add everything else that's remaining in the problem. X and 2x is 3x, and that's going to equal on the other side, 7 plus 2 is 9. Divide both sides by 3, and find that x is equal to 3. Now, once you have your first value, plug it back into either equation to figure out the second. I'm going to plug it back into the first equation, x plus y equals 7. So I'm going to replace x with 3 plus y equals 7. And I'm going to subtract 3 on both sides. So y would be equal to 7 minus 3 is 4. So as a point, my final answer, x was 3, y is 4. Our next example, continuing with problem 1, wants us to solve the solution, or find the solution to the system. 2x minus 4y equals 2, and negative x plus 4y equals 3. So again, to solve systems using elimination, we're hoping that either the x's or the y's will cancel each other out. So 2x and negative x, they're not opposites of each other, but negative 4y and positive 4y. My y values are going to cancel out because negative 4 plus 4 is 0. And I'm going to add what's left. 2x minus x is x, and 2 plus 3 is 5. So I get that x is equal to 5. Now, once I have my x value, I'm just going to plug it back into either equation. I'm going to plug it back into the second equation this time. So that says negative of my x value, 5, plus 4y equals 3. I'm going to add 5 to both sides to solve this equation to get 4y equals 8. And when I divide by 4, y is 2, because 8 divided by 4 is 2. So once you have both your x and your y value, write your point. X was 5 when y was 2. So the solution to this system's at 5, 2. Our next example, we're moving on to problem 2, solving a system by multiplying one equation. So problem 2, number 1, we want to know the solution of the system, negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. So what we really want to use elimination is for either our x's or our y values to cancel out. So negative 2 and 7 and my x's don't cancel, and 15 and negative 5 and my y's don't cancel. So what I'm going to have to do is multiply one of the equations to create an equation that will cancel. So if I look at my x's, negative 2 and 7, there's not a direct way for me to get from negative 2 to 7 by multiplying. However, for my y values, 15 and negative 5, I can make negative 5 become negative 15 if I multiply the entire equation by 3. So I'm going to need to multiply the entire bottom equation by 3. That's going to give me a new equation of 21x minus 15y equals 17 times 3, 51. My top equation's the same. I'm just going to rewrite it so it's over here. Negative 2x plus 15y equals negative 32. And by multiplying the bottom equation by positive 3, what we wound up with was y values that cancel out. So I'm going to cancel out those y values, the positive 15 and negative 15, and I'm going to solve what's left. 21x minus 2x is 19x. 51 minus 32 is 19. And if I divide both sides by 19, I get that x is 1. So once I get my x value, I just need to plug it back into either equation. I'm going to use the top equation. So I'm going to have negative 2 times x, which is 1, plus 15y equals negative 32. And now I'm going to simplify. So negative 2 plus 15y equals negative 32. Add 2 to both sides, so 15y would equal negative 30. And divide by 15. So y is negative 2. So once you have both x and y, just write your final point. X was 1 when y was negative 2. Our next example is number 2 of problem 2. We want to solve the system x plus 3y equals 7 and 2x plus 2y equals 6. So again, I'm looking to see if my x's cancel or my y's cancel. In this case, the x's do not, the y's do not. So I want to find a relationship between the x's or the y's. So I always start with the x's. From x to 2x, I could get those to cancel if the top x was actually negative 2x. So I'm going to need to multiply the top equation, everything, by negative 2. So this will be negative 2x minus 6y equals negative 14. The bottom equation is still the same. 2x plus 2y equals 6. And what I see now is that I have x's that are going to cancel each other out. So I'm going to solve this equation. Negative 6 plus 2 is negative 4y. Negative 14 plus 6 is negative 8. And when I divide both sides by negative 4, I get 2. Once I have my y value, I got to figure out the x value. So I'm going to plug back into this top equation this time. I'm going to say x plus 3 times y was 2 equals 7. Well, 3 times 2, that's 6. And if I subtract 6 on both sides, I get that x is 1. So my final answer as a point, x was 1 when y was 2. So this one's sitting at 1, 2. Next, we're going to look at problems under problem 3, solving a system by multiplying both equations. So multiplying one equation is not going to get the job done this time. I'm going to need to multiply both equations to get an x or y to cancel out. So let's look at number 1 that says solve the system having 3x plus 2y equals 1 and 4x plus 3y equals negative 2. So what I want to do, if I look at my x's, I have a 3x and 4x, which don't cancel out, nor do they have a nice relationship. And I have 2y and 3y, which don't cancel out, and they don't have a nice relationship. So what I'm going to need to do, I need to multiply both equations this time. So I just need to make a decision. Do I want to get rid of the x's or the y's? I'm going to get rid of the x's. So what I'm going to need to do is multiply the first equation by the coefficient of the second equation. So I need to multiply the first equation by 4. The bottom equation is going to get multiplied by the coefficient of the first. So I'm going to multiply the bottom equation by 3. I also need to make sure that my x's, one is positive and one is negative. Well, right now they're both positive, so just stick a negative with one of your coefficients. So I'm going to make it a negative 3 on the bottom that I multiply by, and a positive 4 at the top. So when I multiply, you'll see I now have a system that will cancel out in the x's. So let's get it set up. 4 times 3x is 12x. 4 times 2y is 8y. 4 times 1 is 4. On the bottom, I'm multiplying by negative 3 times 4x is negative 12x. Negative 3 times 3 is negative 9y. And negative 3 times negative 2 is 6. The x's cancel because I have 12 and negative 12. 8 minus 9 would give me negative 1y. 6 plus 4 would be 10. And when I divide by negative 1 on both sides, I'm going to get that y is negative 10. So once I get that y is negative 10, I just need to plug that back into either equation. I'm going to plug back into the first one. 3x plus 2 times negative 10 equals 1. So that's 3x minus 20 equals 1. Add 20 to both sides. That's 3x equals 21. And divide by 3, so x is 7. So as a point, this one would be at 7, because that was x, negative 10, because that was y. Our next problem is number 2 from problem 3. We want to solve the system. 4x plus 3y equals negative 19, and 3x minus 2y equals negative 10. So what I'm going to need to do is look at my x's. I have 4 and 3, which don't have a relationship, nor are they opposites. So I'm going to look at my y's, 3 and negative 2. They don't have a relationship, and they don't cancel yet. So I need to multiply both equations. I need to either get rid of the x's or the y's. It's totally my choice. So since the y's are a positive and a negative, I'm going to get rid of the y's. I'm going to multiply the top equation by the coefficient 2, and I'm going to multiply the bottom by the coefficient 3. When I do this, since they were already positive and negative, I should be left with two equations that are going to cancel out one of the variables. So 4x times 2 is 8x. 3y times 2 is 6y. Negative 19 times 2 is negative 38. On the bottom times 3, 9x minus 6y equals negative 30. And then I'm going to simplify all of this, because right now I have a positive 6y and a negative 6y. So they cancel. I have 17x equals negative 68. And when I divide by 17, 17 goes into 68 4 times. So this would be negative 4. Once I have my x value, I need to plug it back into either equation to figure out y. I'm going to plug back into the top. So 4 times x was 4, plus 3y is negative 19. So this would be 16, negative 16, plus 3y is negative 19. Add 16 to both sides, so 3y is negative 3. And when I divide by 3, y is negative 1. So as a point, x was negative 4, y was negative 1. So this one's sitting at the point negative 4, negative 1. Okay, the last two problems we're going to take a look at is how to see if you have infinitely many or no solution when you use the elimination method. We'll see that it's very similar to the substitution method in regards to the final result. So problem 4, number 1, we want to solve the system. 2x plus 6y equals 18, x plus 3y equals 9. So none of my variables cancel out to start, So what I'm going to need to do is line up my x's and ask myself, is there a way to get x and 2x to cancel out? Well, I know the bottom one could cancel out if that was a negative 2. So I'm going to multiply the bottom equation by negative 2. So the top one's the same. I'm going to copy that first. The bottom one, however, is going to be negative 2x minus 6y equals negative 18 after I multiply everything by negative 2. So the x's cancel out, which is what I wanted, but the y's are also canceling out. So when everything cancels out, we need to write down that means there's 0 on that side, equals 18 minus 18, 0. And if you remember, when you're left with a true statement, 0 does equal 0, we called that infinitely many solutions. So true statement left, infinitely many solutions. Now our last example is number 2 from problem 4. We want to solve the system negative 2x plus 5y equals 7 and negative 2x plus 5y equals 12. So what we're going to do, first look to see if anything cancels. It doesn't. So if I line up my x's, negative 2x and negative 2x, I could get these to cancel if only one of them was positive. So I'm going to need to multiply one of the equations by a negative 1. So the top equation I'm going to leave the same. Negative 2x plus 5y is 7. The bottom equation, I'm going to change this now by multiplying everything by negative 1. So positive 2x minus 5y is negative 12. The x's will cancel. The y's are also canceling. So all I have left is 0 on the left, and 7 minus 12 is negative 5. So 0 equals negative 5. That's not true. We would call this one no solution. False statements result in a no solution answer. So this concludes our lesson on being able to solve systems of equations through elimination. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.